We're Bio-Inspired Guitarist, an interdisciplinary senior design project for spring 2025. Across the world, music and guitars and other guitar-like instruments play important roles in most cultures. Whether you're just starting to learn how to play, or you've been playing for years and are practically a pro, reading and engaging with music is important. It's part of what makes us human. When facing limb difference, whether from birth or later in life, people are removed from engaging with music in this way. Current prosthetics are bulky, lack precise controls, and typically weigh 3 times the average human hand. That's where we come in. We're building a lightweight robotic prosthetic to play the guitar. To be able to play the guitar, the joints will need to be able to flex independently of each other. Additionally, the finger needs that adduction sideways motion. We created a system that uses 3 pulleys and 1 electric motor to achieve lifelike motion in the finger. Motor and gear to control the flexion at the first knuckle is located inside the palm. Each pulley has its own servo motor housed in the forearm to distribute weight. Channels are built into the finger for the string of the pulley system. Each joint has its own string, which is looped over the pulley. Metal pins hold the finger together at the joints. Focused on achieving realistic finger motion instead of making a full-scale arm, so below the forearm is a box that contains all of our wiring and controls. Before the hand can move, it must be reliably powered. The whole system is plugged straight into the wall, the only cord a user will need to interface with. Then a power splitter separates our power to 2 branches. One powers the Raspberry Pi, the brains of the operation. This will control all motion of the robot, but it will also power and control a circuit that operates a pressure sensor to see how hard the finger is pressing on the guitar string. The other branch goes to a converter to turn AC power into 12 volts DC power. The 12 volts powers the electric motor. This further branches to a 5-volt step-down converter to drive a board that can control up to 16 servo motors. This is all hidden inside the box under the hand. We're approaching movement 1 note at a time, just like learning to play the guitar. The program will move to a specified string, return to a neutral position, and then move to the next string.
The software is designed to be highly modular, with the Guitar Bot module in charge of the whole operation. A GUI allows users to input information and send commands back to the control unit. This then looks up angles for the individual joints within the finger. The angle information is then sent on to a motor control, which will then execute the necessary angles using servos and a servo controller. Feedback is achieved through a pressure sensor at the tip of the finger. This pressure sensor lets the main program know when the right amount of pressure has been received in order to fret the note correctly.
There's plenty of work to do before this hand can help you play a sold-out show. But we think it's a pretty big deal.